In AP Stats in 1040, we'll look at 90%, 99% confidence interval, which means we have different critical values. You don't need to worry about that. When we're working at your critical value, you're just going to work with 1.96. And if that's all you remember, you're like, I don't remember why, but it's 1.96 good enough for now. But the reason why is because in a normal distribution, that's how many standard deviations we go out to get to 95%. Now, we're also going to look at the standard deviation of the statistic. This is where we're going to get some new values, some new formulas here, okay? So, when we're looking at our formula here, we did our point estimate, our best guess for means was our sample mean. We're going to use 1.96 as our critical value. Then what we're going to do is we're going to take our standard deviation and divide it by the square root of n. Remember, n is our sample size. And that's, when I times these together, that's how I get the margin of error. And then I can add and subtract that to get our actual confidence interval. Okay, that's our formula. When we're working with proportions, our formula is going to be it's going to have some similarities and some major differences. We're still going to use 1.96, but to calculate the standard deviation of the statistic, we're going to have the square root of p hat. Remember, that's this guy right here. And we're going to do 1 minus p hat, and then we're going to divide that all by n. When we multiply this all together, that'll give us a margin of error, which we can add or subtract, and that gives us our confidence interval. Now, these look scary, I realize that, but just try a couple examples with me and you'll see, oh, that's not too bad. And you don't have to memorize them, you can use your notes, okay? But just try these out with me. Okay, if you were here, which would have been awesome, we would have done an activity where we would have taken the heights of all the females in our class. You're not here, so I just used an example of a previous class, okay? I'd have everyone go and measure their height in inches, and then we would use our calculator to find the mean and the standard deviation. I've already done that for you. So here I took 19 females, sample size is 19. I got that the average height is 64.63, and the standard deviation is 3.85. Now, I want to create a confidence interval to show what we expect the actual height of females at Hunter to be, because this is just a sample from my class, and granted my class might not be a very random sample, but it's what I have to work with, okay? So let's use our formula. Remember, we wrote down that to get our confidence interval, we're going to take our point estimate, which is our best guess. Right now this is our best guess of what we think the average height of girls at Hunter is. Then we're going to take our critical value and times it by our standard deviation over the square root of n. Here's our standard deviation. Here is our sample size. Let's just plug this all in. So I've got 64.63 plus or minus 1.96 times standard deviation 3.85 divided by the square root of 19. I'm just going to go get my calculator and plug that in. When I do, I get 1.73. So 64.63 plus or minus a margin of error of 1.73 inches. Now what that means is that I'm going to add 1.73 to 64.63, and that'll give me the upper limit. Then I'm going to subtract it, that'll give me the lower limit. So let's do that. 64.63 plus 1.73 is 66.36. 64.63 minus 1.73 is 62.9. Now, this is a 95% confidence interval. How I interpret this is I would say I am 95% confident that the females at Hunter High, the average height is somewhere between 62.9 inches and 66.36 inches. This is 5'2", and that's 5'6". So, if you're a female, you could think of your height. Does that seem about right? And I would say, yeah, I think the national average for females is around 5'4". And this is right That would be right in between those. 64 is 5'4". Now, does that make sense how we use this formula to come up with our confidence interval? I hope so. If it doesn't, feel free to email me and we can talk about it. That's how we use, that's how we do a confidence interval for means. Now, what about proportions? How would we do that? Let's actually ask a different question here. We want to know what proportion of this bucket of beads that I have is blue. Maybe you've seen this before, but this is, I hope you can see that all right, a bucket of about 15,000 beads. It's a lot of beads. I really hope I don't drop it. Now, some of those are blue and some of those are red. What proportion of these are blue? Well, what I did was I took a bead counter here, and I said, let's do a sample of 100. And I stuck the bead counter in here, and it pulled out, oh, come on. There we go. It pulled out 100 beads. Hopefully you can see that. Then I said, how many of those 100 are blue? Well, in my sample, I got 32 out of 100 were blue, which gives me a p-hat, a sample proportion of 32.32. So what I'm going to do is now use my formula for proportions to come up with a confidence interval. Because remember, again, with my sample, it won't always be the exact same as a population proportion. There's going to be a margin of error of where it's going to be slightly different, but we can still be pretty confident of where the actual population proportion is. So our formula said we're going to take our point estimate p-hat, take our critical value 1.96, because we're doing a 95% confidence interval. Then we're going to look at the square root of p-hat, 1 minus p-hat, and then n in the denominator. Our sample size here was 100. And that's a great sample size. As a rule of thumb, as your sample size gets bigger and bigger and bigger, it makes your margin of error get smaller and smaller and smaller, which gives you a more precise confidence interval. All right, so let's plug this in. My p-hat was 0.32. Critical value is 1.96. And then we're going to do the square root of 0.32, 1 minus 0.32, and the sample size of 100. I'm just going to go and plug this whole thing into my calculator. And I got 0.091. 0.32 plus or minus, and I'm just going to round that to 0.09. So what this means is I have a margin of error of about 9%. That means if I add the 9, that'll take me up to 0.41, and if I subtract the 9, that'll take me down to 0.23. Thus, here is my confidence interval. I am 95% confident that the proportion of blue beads in that bucket is somewhere between 0.23 and 0.41. So 23% to 41%. When I originally put all the beads in there, there was 33%, which that's pretty darn close to what our sample proportion came up with. People have taken some out and lost some, but I would still assume it's between there, so that's accurate. Now, what if we did this again and got a different sample? The point is our confidence interval will still be able to capture that true population proportion through the margin of error. In fact, it does that if we were to look at many, many times, 95% of the time. That's where 95% confidence interval comes from. So this is how you do a confidence interval for proportions. And that's it for confidence interval. Your assignment is pretty short. I think it's just got like 3 or 4 questions. Your quiz should be pretty easy. If you have questions or there's still confusion, please email me, or we could do a virtual office hour or something like that, and I'll make sure you understand, okay? All right, guys, enjoy your Taco Tuesday. I'll see you next time.